Next topic is large scale propagation channel. So basically large scale propagation describes how average signal strength changes over long distance when we are transmitting from the transmitter and till it reaches the receiver. That is, in simple terms, we can say large scale propagation as the signal strength is anyhow it is going to decrease from transmitter to receiver when we are going on certain distance. You can see the diagram, and user is near the tower at 30 meter, 100 meter and 150 meter, and whenever he is moving away from the base station the signal will get affected and the signal may get interrupted. So these can be affected by distance, terrain, building, weather condition and obstacles. So classification of propagation effects are small scale and large scale fading. When we are going through large scale fading, the distance it is mainly depend on distance. Whenever we move a longer distance, the fading is larger. And small scale fading, these are not depend on distance, it is mainly depend on multipath propagation, like obstacles, like building or mountains or terrain whichever is near to your propagating medium. So this multipath it is mainly depending, and these are large scale fading are mainly used for shadowing, and small scale fading may cause fast fading or rapid fluctuations can be observed in small scale mode. So it is very difficult to trace these original signal when it is undergoing fast fading. And large scale signal, it is mainly slow variation, and these small scales or rapid variations. And the below graph can represent small and large scale fading channels. You can see a graph with more fluctuations, that is undergoing small scale, and a linear graph may show you these are large scale fading model. And this is free space propagation model. In free space propagation model, we mainly assume first transmission equation, and there will be no obstacles. The communication is happening through line of sight, that is there is no object or interferences from transmitter to receiver, and it is considered under an ideal environment in case there is no obstacles, mountains or terrain regions. So the Frisk transmission formula you can note. So this is your Frisk transmission equation. PR equal to PT GT GR lambda by 4 pi d the whole square. You can also replace this lambda by C by F, where C is velocity of light and F is the frequency. Here PR and PT are transmitted and receiver power. D is the distance between the transmitter and receiver, and lambda is your wavelength. This is your free space path loss. So in this, the path loss increases with distance and frequency. And the formula for free space path loss is 20 log D plus 20 log F plus 32.44. These are mainly used for satellite communication and microwave links. And usually path loss, we have came this term across multiple times in this subject. This is the reduction of signal power as it propagates or moves over certain distance from transmitter to receiver, and these are caused by absorption, reflection, diffraction and scattering. The formula for path loss is Pt minus Pr, where Pt is the power of the transmitter and Pr is the received power. You can see the diagram. It is very well explaining when a signal is transmitted from transmitter to receiver. There is multiple obstacles like diffraction, free space, scattering and reflections. And h is the height of the obstacle and d is the distance from transmitter to receiver. So this is your path loss exponent n depends on the environment. PR is directly proportional to 1 by d the whole power n. That is, the receiver power entirely depends on the distance between the transmitter and receiver. For example, if the receiver is very close to the transmitter, then path loss is very minimum. But when the receiver is very far away from the transmitter, you can expect a heavier path loss. So you can see when n is 2, it is free space. When n is 3 to 5, it is urban, and n is 4 to 6, indoor. Since we'll be having multiple gadgets using the same frequency components. And this is log distance path loss model. We can discuss in the next class.